This is a video for all my fellow Schaubergians out there. Just want you guys to know I got my mind set on building the suction turbine, and I'm hard at work. So what I did today, I learned how to use a scroll saw, and I made these ribs for my pottery wheel. So what I've come to the conclusion that I want to do is come up with a process, the implements, the tools, and the materials to make building these Schaubergian machines, not build them, to cook them up, in a sense. I want to make the process like cooking a dish. So I'm just in the process of building the tools and figuring out the steps of how I'll go about things. So here, this is a oak 1/4 inch meandering membrane rib. So the idea would be that this is a 10-inch rib, so that would give you a 20-inch meandering membrane. And the idea is that on a 20-inch bat, I will throw approximately 10 pounds of clay and flatten it out into a disc. And then I take this rib and I impress this rib into the clay to achieve this profile. So this was my first attempt. Actually that was my first attempt. That's my first attempt. It was quite awful to cut, but I figured out how to clean things up. So I'm gonna cut another one out of high density polyethylene. The math I used here is, I think I'm going to explain this in other videos. I want to keep this nice and quick. But here, I got the rib. I'm going to show you guys a couple other things. So I'm going to be basing my design off of page 181, the suction turbine. This particular article from Implosion magazine. Okay, so I know how to make these in copper now, and what I'm going to do, I have a half egg shaped hub. I've been playing around with how to create connections. So as you can see here, this you have to flip this upside down. These horns, this half egg shaped hub and a meandering membrane on top, will all nest inside of a drum with a ring around the edge to reflect the jet of water. So this is the half egg shaped hub described in that article. I'm gonna melt all this down. This is just me playing around right now, but I've got a sense of how I'll probably make this opening bigger, so the water will be sucked up from the drum through 3 of these pipes into the half egg shaped hub, and then centrifuged through a meandering membrane similar to this one. So I've been making these, I'm trying to figure out a quick way to make these meandering membranes. So I'm probably gonna make some slip casts, some ceramic versions, and basically some dishes into which I can pour wax and then extract the form for electroforming. That's the idea. So as you can see, I've kind of figured out now the idea of joints, and I figured out how to pour joints, and basically okay, so what I'm attempting to do here is to pour a connection between the horn and this half egg shaped hub. I don't know if it will leak or not. Let's see. Yeah, it was leaking. Where's it leaking from? Okay, I gotta fix that. So I'd have a part, which would be this part, which I pull from the membrane, or from the copper horns. And then I have this part, which I pour as well. And then I would pour in the joint to connect the two. And as you can see, the joint needs to be cleaned up, and I'm going to increase the size of this probably to 2 inch. This currently is about 1.5 inch, so I'll increase this bore to 2 inch. So I'm almost ready to throw these membranes. I got a 20-inch bats, and then I bought some really nice 20-inch hydrostatic bats. I'll probably use these because they'll allow me to leave the clay on, slip cast, and you know, they don't warp in the same way as these MDFs. So I have a lot of work ahead of me, but I'm gonna put myself 100% into this, and I will build this turbine. I will do it. So just another point, guys, the shaft for this turbine. Okay, so imagine there's gonna be 3 of these horns, which will fit into these 3 openings here. The horns will attach to the shaft, the hub will attach to the shaft, and the membrane, which sits on top of this, will also attach to the shaft. And then I'll either have direct drive or a motor off to the side with the pulley to spin it up. Okay, the diameter of the drum is 22 inches and the diameter of my meandering membrane is 20 inches. So that gives me a very small space with a small air gap. So space for the peripheral baffle ring, or is it the baffle rings? The scalloped ring around the periphery, and a small air gap, and then the meandering membrane. So it'll be a very tight fit. It will seal within the drum. There'll be a flanged bearing on top and a bearing in the base. And I'm probably going to use 1.5 inches. I have not found the shaft I want right now. Stainless steel shafts are very expensive. Ideally, this connection here would be splined. This is getting really complicated, so I gotta keep it as simple as possible for the first iteration, but I know it's not a great demonstration apparatus, but those of you who understand Schauberger will understand. So this is going to spin in a counterclockwise direction, and the water will be sucked up the oral pipe in clockwise fashion, and it will be centrifuged counterclockwise through the meandering membrane. All right, I'm going to cut another rib, 10-inch radius on the scroll saw. And action. Okay guys, I think I have decided that this spline is no good. I mean, it was practice, but I'm gonna use, so following figure 33 here, if you just take a close look at this meandering membrane, you notice that the amplitude of each successive wave decreases towards the periphery. So that's what I'm going to do here, working with a 10-inch radius, 20-inch meandering membrane, and I think I'm going to do like a decreasing wavelength like this, with the blade being right here. I think I might increase the amplitude from 1 inch to maybe 1.5 inches, so that when I make the bat, the piece of clay that I'm going to press in will be about, say, 2 inches. So that gives me a little bit of space on the trough of the wave, between the trough of the wave and my pottery bat. So I'd have clay here and then my pottery bat here. So I'm gonna draw this out a couple more times and then cut it out of the paper, trace it onto some high density polyethylene, rig up the spline saw and cut it out on the spline saw. So what I did here, I have 10 inches to work with. I split it up into 1 inch segments. I give myself 3/4 of an inch for my shaft, because I'm using an 1.5 inch shaft, a 1/2 inch for spacer and fastening, and then the waveform starts. So it has an amplitude of 1 inch, and then I reduce it by about 1/4 inch at each consecutive wave. The angle also reduces from 45, so it goes from 40 down to about, I think this is, what is this here? This is about maybe 22 degrees, and then I'm looking at 22 degrees, maybe that's about 32 degrees. So that particular number of 32 degrees, it is mentioned that the pressural component, this means the suctional force must be and so remain the predominant force throughout the whole sequence of motion. The pressure components, which exert the more subordinate pressure, must never act in a purely vertical direction, but always tangentially and at an angle of about 32 degrees. And for this reason, a cycloid spiral space curve is always produced so that the moved mass unwinds from the periphery towards the center in such a way that the center of gravity of the unequally heavy bipolar masses, the oxygen atomic weight 16, is displaced into the center of the axis. Here, the oxygen is cooled, falling positive temperature gradient, and in this condition is encircled and bound, emulsified, or consumed and digested by the hydrogen of opposite polarity, which actually has an upward velocity of about 2 meters per second. The product of this emulsive process is the uroprocreative act. The uroprocreative act is dimagnetism. So something to note here, I mean, everybody's, you always hear all this talk about room temperature, superconductivity. Isn't this the same thing? I mean, it's not room temperature, but it's not, like liquid nitrogen temperatures. So what was my point there? My point there was the 32 degree angle. So this waveform I was making before, the angles are just not right. I had to work on some graph paper to really get it down. So I'm gonna work with this. I'm gonna play around with the amplitude, figure out the right sort of proportions for this meandering membrane. Okay, another day, another video. I have been making many of these ribs now, and I have settled on this particular profile. So there's my rib for the meandering membrane. Excuse me. And then I'm gonna cut this out. This is gonna be my rib for the lower membrane, or sorry, for the lower half egg shape. So I'm going to trace this now out onto a thicker piece of paper. I'm going to cut this out, trace it on a thicker piece of paper, bring it outside, tracing onto some high density polyethylene. Unfortunately, I made this one, but it's wrong. So what I want to happen, if you can visualize here, I want the half egg shape, this line here, this line, and then this wave. So the half egg shape will have a flange at the top. It will be open. It will be open in the top so that I have access to the 3 pipe openings so that I can solder the Kudo horn intake pipe to the hub from the inside of the hub. And then I will affix the lower membrane to the hub. I'm not sure how I'll do this. Maybe solder, I'm not sure. Rivets. Probably like a very low profile rivet. So this flange will match the profile of the 3rd stage of the membrane. And I'm gonna have to figure some things out as I go. A little problem I'm having right now is the input shaft. I think I should use either a splined or a hex shaft. So what I'm trying to figure out right now is, basically I'm trying to source a shaft. It would be nice to have it so that when I go to make the clay models, I have the exact profile that I need. Because my plan here is to take these ribs and produce the upper lower membrane, the hub. I can already make the horns. I know how to pour the joints. What I need is a 1.5 inch hex shaft at about 4 feet. I need some 1.5 inch hex bearings with flanges. And that would solve a lot of problems for me right now. But my plan is to make this stuff out of clay and then to slip cast it and create molds. And then from there, I will probably create a few clay versions, bisqueware clay versions. And then I'm also going to attempt to pour in and extract wax from the slip cast and other materials. So that's where I'm at right now. I've gotten pretty good at using the spline saw. I would say, like, this is the profile I cut out of paper. And that's the profile I cut out of the high density polyethylene. So there's these you can imagine are like teeth, which will dig into the clay, and it's not gonna, the rib won't do all the work. I'll still have to do some pressing and forming, but the idea is that the rib will help me to achieve the same profile over and over and over again. And these teeth, you can see, each one is a little bit different. It tapers. These teeth will be impressed into the clay. The clay will then be slip cast, which is basically the process of pouring plaster over clay. And once that's cured, I can pull the clay out of the plaster mold and soap that mold and use that mold, maybe hundreds and hundreds of times. So that will save me from having to trim every time. Trimming is it's very messy. Trimming wax is exceptionally messy. Anyway, I'm rambling, so it's Saturday morning. My plan today is to cut out this rib, go down into the basement, get the electroforming tanks, the filter swapped out, just do a little bit of maintenance down there. The thing with electroforming right now is I'm not doing it. I'm leaving it. I'm gonna make everything first and then start electroforming. So maybe I'll start electroforming in October, if I'm lucky. So the ratio, the proportions of this half egg shape, for anyone who's curious, it's a ratio of about 1.54 to 1. So 6 to 9 1/4. 6 to 9 1/4, which just so happens to work out to be the geometry of the cosmic egg. Without me really even having to do much work, I just kind of drew it. But what I was, so it's the lower section of this egg here, A, C, D, right? So if you flip that, if you flip that there, so there's the lower section of the egg. This is a rough sketch. You got your membrane, cudal horns, down into the drum, a hex, 1.5 inch hex shaft, and then I gotta find a way to spin up the shaft. So do I use a pulley? Do I use sprockets? Because a part of me would love to hook my bike up, right? I'd love to hook my bike up to the input shaft of this turbine, for the reason that I think it would be the best way to feel the power, to feel what's going on within the machine. Because you have to imagine, in order for this machine to run, you're gonna have to close it up. So I could make a clear lid so you can see inside, but I don't think, I mean, yeah, that's a possibility to make a clear lid. However, it would be interesting to feel in the same way that you feel the acceleration through a turn, or in skiing, or the sailing faster than the wind. It would be very interesting to feel what's going on within these machines, what's happening to the water. So one thing I will say is I've been making these meandering membranes on the pottery wheel. And I mean, I know when I throw over 10 pounds of clay on a pottery wheel, when I pull my foot off the foot pedal, that wheel continues to spin just by way of the inertia and the flywheel effect. And I do see what's happening here. Schauberger's making dynamic flywheels, and the water is a key component. The circulation of the water is a key component. So, a little bit of rambling here. Probably just avoiding doing the work, so I better get to work.